Hello everyone, welcome back to Digital Lesson for Students by Department of School Education, Nagaland. I am T. Pungudi from C.D. King Higher Secondary School, Science Stream, Jotsama, Kohima. In the last session, we learned how to evaluate the value of determinants of order 1, 2 and 3. And later we learned how to find the area of the triangle using determinants. In this session, we are going to learn the properties of determinants, and later we are going to solve some problems using the properties. Yeah, let's start with the question here. There are 6 properties, the main properties. The first one is determinant of A is equal to determinant of A dash. Determinant of A is equal to determinant of A dash. We already know what is A dash. A dash is the transpose of A. How do we get A dash? Interchanging rows and columns. So let us take a determinant as A1, B1, C1, A2, B2, C2, A3, B3, C3. When we evaluate this, suppose we are getting a value alpha. Say alpha. We are getting a value alpha. Okay. Now we take the transpose for this matrix, that is determinant of A dash is, that is changing the rows into columns and columns into rows. So A1, B1, C1, A2, B2, C2, A3, B3, C3. Then you evaluate, you will get same alpha. This one you can easily check by taking a 3 by 3 matrix or 2 by 2 matrix and find the determinant of A, and then later you find the determinant of transpose, you will find the answer same. It is true for all the determinants. Then the second one is Ri getting interchanged with Rj, Ci getting interchanged with Cj. There we took the transpose, that means we are interchanging the rows into columns and columns into rows. But in the second one, we interchange any 2 rows or any 2 columns, not everything, only any 2 rows or any 2 columns. See, this is the second one. Let us take the same determinant and we are getting, when we evaluate, we get alpha. Now I wish to interchange this row 1 and row 2 or row 1 or row 3. So it's up to us. So we will interchange R1 with R2 and R2 with R1. So we get, this is also determinant that is equal. This is new determinant. Okay. So let it be delta dash. I'll give you a new name. This is delta and this is delta dash, the new determinant now. So this will be A2, B2. That is R2 will go here and R1 will come here. C2, A1, B1, C1, A3, B3, C3. Here what may be this value? This is equal to minus alpha, negative of this value. It happens for any row, any 2 rows or any 2 columns. If we interchange this C1 and C3 also, we get similarly. You can check this by taking simple determinants and find out. Then the third one is any 2 rows any 2 rows or columns are identical or proportional, then the determinant will be equal to 0. Any 2 rows or columns are identical. What do we mean by identical? Same elements. And proportional, multiplication of 1 row. See, let's see an example. Let us take delta equal to A1, B1 and C1 and A2, B2, C2. This is A1, B1, C1. See, here the first row and the third row are identical. The elements are same. In that case, this delta will be equal to 0. This delta will be equal to 0, that is determinant is equal to 0. Then what is proportional? For example, here 2, 4, 3, 1, 0, 2 and this is 4, 8, 6. if you see this row and this row, are they proportional? Yes. 2 times of 2 is 4, 2 times of 4 is 8, 2 times of 3 is 6. Otherwise, 2 by 4 equal to 1 by 2, 4 by 8 equal to 1 by 2, 3 by 6 equal to 1 by 2. They are proportional. In that case also the determinant will be 0. These properties are very useful to solve the determinants. It will make the calculation easier. In that way we can find the answers quickly. Then the fourth one is Ri takes k times Ri, Ci takes k times Ci. This operation we have seen already in the matrices, elementary transformation also we did this. So the same operation if we do here, suppose this is alpha, then I multiply a k, a non-zero scalar k a1, k b1, k c1, then a2, b2, c2. This is R1 takes k R1. R1 takes k R1. That means we multiply all the elements of R1 with k and put it in R1 again. Then the last one is, this is A3, B3, C3. So A3, B3, C3. See what we have done here? We just multiply the row 1 with k, non-zero scalar k, and put it in the same row. Okay. Here what will happen? What may be the value of this, the determinant? So this will be equal to k times of alpha. K times of alpha. If you multiply scalar, non-zero scalar with any row or any column, you get k times the determinant, old determinant. So that's how we have written Ri takes k Ri, Ci takes k Ci, the new determinant will be equal to k times old determinant. Using these properties, we can take the common factor of this one. So this one we can write it as k times a1, b1, c1, a2, b2, c2. In this way we use in the problems. Using this property we can take k as a common factor and then we can write in this way. Then the fifth one, is if sum or all the elements of a row or column are expressed as sum of 2 or more terms, then the determinant can be expressed as sum of 2 or more determinants. I will show you an example now. Determinant equal to, suppose this is a1 plus alpha 1, b1 plus alpha 2 and c1 plus alpha 3. Then this is a2, b2, c2, and this is a3, b3, c3. Okay. Here what we have found, the first row is written as sum of 2 terms. See, a1 plus alpha 1, b1 plus alpha 2 and c1 plus alpha 3. We can split this determinant as sum of 2 determinants. See, we can write like this: a1, a2, a3, b1, b2, b3 and c1, c2, c3 plus, then now we take alpha 1, alpha 2, alpha 3, b1, b2, b3, c1, c2, c3. See, now it is easy for us to expand. So when sum or all the elements of a row or column are expressed as sum of 2 or more terms, it is possible with any number of terms. If it is expressed as sum of 4 terms, then you can split it into 4 determinants. Then the sum of 2 or more terms, then the determinant can be expressed as the sum of 2 or more determinants. Okay. For example, there is here also beta 1, even this here beta 1, beta 2, beta 3 is there. Then how do we expand? Here we get like this: plus beta 1 plus beta 2 plus beta 3, then here beta 1 plus beta 2 plus beta 3. Then this will split again. We take only this one for one determinant, and with the second determinant we take this for the second row. And here again it will be split into two determinants. For the first determinant we take these elements, and for the second determinant we take beta 1, beta 2, beta 3 as second row. So we will get 4 determinants. So you have to be careful when you are expanding the determinants. Then next, the sixth one is very important. Already you know the operation, how we do it. R1 takes R, here Ri takes Ri plus or minus k times Rj, and Ci takes Ci plus or minus k times Cj. That is multiplying each element of row or column and adding with the corresponding elements of Ri or subtracting to it from it. Then that goes to Ri row. So in that case the determinant remains changed. This relation will not change the value of the determinant. This operation, when we use this operation in the determinant will not change. For example, A1, B1, C1, A2, B2, C2, A3, B3, C3. It gives us alpha. Let's take alpha. Then I am going to do R2 as R2 plus m times R3. M times R3. What we are going to do is we will multiply this row 3 with m scalar. We multiply every element with m and then add those elements with the corresponding elements of R2, and we will replace this with the new elements. Let us see, delta equal to, the first will not take any change and the third also will not take any change, only this R2 will take. So how do we get? We multiply R3 with m. So we multiply this with m and add this. So A2 plus m times A3. Hope you get it. Then we multiply this with m and then adding to the corresponding element. And this one C2 plus m times C3. See. Then what can be this value, determinant value? It will be same, alpha. This is very important. And there are 6 properties. Let us recollect once again. The first one is determinant of A equal to determinant of A dash. Interchanging rows and columns will not change the value of the determinant. The second one is if we interchange any 2 rows or columns, the new determinant will take the negative or with sign change. It will change its sign. And the third one is if any 2 rows or columns are identical or proportional, then the value of the determinant is 0. Then the fourth one is Ri, this relation, multiplying any row or column by a constant, by a scalar, non-zero scalar, then the determinant will take like this. New determinant will get k times that old determinant. And the fifth one is if some or all the elements of the row or column are expressed as the sum of 2 or more terms, then the determinant can be expressed as sum of 2 or more determinants. The sixth one, this relation will not change the value of the determinant. That is multiplying each element of a row or a column or adding with or subtracting from another rows corresponding elements, then the value of the determinant will remain the same. Apart from this, we have 2 more results. That is also useful for us when we evaluate the determinants using properties of determinants. If all the elements of a row or column are 0, then determinant value is 0. It is obvious. If you evaluate the determinant, the value of the determinant will get 0 only. If all the elements of a row or column are 0, then the value of the determinant is 0. Then the next one is very important. You find it very often in the question papers. If A is a square matrix, note this point, square matrix of order n, then K is any scalar, non-zero scalar, such that order n and K is any scalar, then determinant of Ka will be equal to K power n times determinant of A. This is very important result. Please note down in your textbook. The present one which we are using, this is not given. So you write somewhere in your textbook this one. If A is a square matrix of order n and K is any scalar, then determinant of Ka is equal to K power n into determinant of A. So let's take, suppose if we take A is a square matrix of order 3. It's a square matrix of order 3. Therefore, n equal to 3. Order n, isn't it? N represents the order of the matrix. Therefore, what is the order of the matrix here? 3. Therefore, we take n equal to 3. Then let us just assume K equal to 2. K equal to 2. Now, I just want to find out 2 times A, determinant of 2 times A. We can easily say that this will be equal to 2 power 3 times determinant of A. That is A times determinant of A. This type of question will be asked in the 1 marks MCQs. If A is a square matrix of order 3 and K is 2, then what will happen? Determinant of 2A is equal to multiples. The choices will be given, option 1, option 2, option 3, option 4. Then if there is 8 times determinant of A, that is the correct answer. These two are very important results. Okay. Next we will see some problems from your exercise, evaluating the determinants using properties of determinants. If it is mentioned properties using determinants of properties of determinants and evaluate, then if it is mentioned in the question using properties of determinants evaluate, then we must use at least minimum of 2 properties before we expand the determinant, because it will make easier only. We can easily find the answer. And sometimes students are confused what property should be used, which problem. Every problem has its own way of solving. All those confusion will come. So I tell you one thing, you can use any of this. You are free to use any of this. Unlike elementary transformation, we can use row operation and column operation in the same question. I did not say that in the same step, same question. Maybe in the first step you are using row 1 plus 2 times row 2. In the next step you can use C3 as C3 plus C2. It's possible. But in elementary transformation, if we choose to use row transformation, we use only the row operations. And then if we choose to use column operations, we use only the column operations. But here in the same problem, we can use our row operation and also the column operation. And we have to remember one thing, this is not applicable. We cannot do this, mixing up rows and columns and putting in row value. No, this we cannot do. This is in one step, in the next step you can do this, but not in the same step. You have to be very careful. And also you can add or subtract any number of rows like this, or any 2 only also you can do it. And column also you can do C1 plus or minus C2 plus or minus C3, you can do this, but R1, R2 and C1 is C1 by C2. These two we cannot do. Multiplication of rows or division of columns is not admissible. Using these properties only we have to do it. And do remember, you can add or subtract the columns and rows, and you can use the row operation and the column operation in the same problem, but not in the same step, and also multiplication of rows or columns or division of rows or columns are not admissible. So, you have to be very careful. Let us see some problems from your exercise. Determinant of XA, X plus A, we have to prove this, prove that YB, Y plus B, ZC, Z plus C is equal to 0. So, we will prove this left hand side is equal to 0. Okay. So, solution, let us take this determinant as XA, X plus A, YB, Y plus B, ZC, Z plus C. One easy step, I tell you, you try to make any row or any column as it has the same elements with other rows or other columns, same as the other rows or other columns. The first step is you have to think for it, whether it is possible for us or not. See, for example, you see that first column and the second column. If you add this and put here or here, it's up to you. You put here or here, but if you add this X plus A, Y plus B, Z plus C, we get as this. So, by the property third, any two rows or columns are identical or proportional, then the determinant is 0, easy. So, let me write C1 as C1 plus C2. We are going to add C1 and C2 and we will put it in C1. Okay. So, it will be, you can write it in C2 also, same operation you can write it as C2 as C1 plus C2. X plus A, Y plus B, Z plus C, then second and third will remain the same. X plus A, Y plus B, Z plus C. See, by the third property we get C1 and C2 as identical. So, we can easily say that this is equal to 0. But please try to write the reason in the bracket when you are applying any property. In short way will do, so that the examiner will be impressed to give you more marks. You can say like C1 and C3 are identical, then the determinant is 0. In short way, just you have to write the reason why it becomes 0. You are using a property, isn't it? It's a small problem, so we did with only one property. If not, for 4 marks minimum, you have to use 2 properties before expanding the determinant. You can directly expand this determinant, how we learned in the last session. Still you will get 0 value only, but it is very simple now. You see, using the properties of determinants, within a single step you are getting the answer. So, you learn the properties of determinants. It is interesting. Only the thing is, you should know these properties very thoroughly and how to use it, that is very important. And you have to see when we use these column transformations, see, we move along like this. See, we add the elements like this. When we use the column operations, see, we move like this, left to right. But when you use the row operation, we move top to bottom. So, we do the elements operations like this. So, you have to be very careful. When you are doing with the row operation, you have to move top to bottom, and when we are up and down, and when you are doing the column operation, we move from left to right. Yeah, these are easy things, easy tricks. We will see one more. Prove that minus a square ab ac ba minus b square bc ca cb minus c square is equal to 4a squared b squared c square. This is also an interesting problem. So, let us take delta as minus a square ab ac ba minus b square bc ca cb minus c square. Okay, it's very simple. Here we are going to use the property 4. I already told you, using this property we can take a common factor outside from the determinant. You see, the column or row, it's up to you, you can do it in any way. If you see the first column, A is common, we can take A as a common factor, and from here B, and from here C. You can do with row wise also. Here also A is common, B is common, C is common. Okay, I am going to take from column wise. So A, from the first column I am taking the A outside. So we get minus A, B, C. And from the second column I am taking B outside. So that is A minus B, C. And from the third column we are going to take C outside. So this is A, B and C minus C, isn't it? So we have taken A, B and C from column 1 and column 2 and column 3. And here we have used the property number 4. You can write here, since C1 as A C1, no, C1 divided by A. You can write like this because we are taking out A, and C2 as C2 by B, and C3 as C3 by C. Okay, then the determinant will be equal to ABC times K times the delta as per the property. Here what is K for us? ABC. So ABC times this one. Okay, then next, see again we can use the same property. Now in row 1 we have A, and row 2 we have B, and row 3 we have C. So shall we write as ABC into ABC. From the first row, if we take A outside, you get minus 1, 1, 1. From the second row, 1, minus 1, 1, 1, 1, minus 1. Okay. So if we expand this determinant, we will get the RHS. Okay. You can directly expand from here because already you have used the properties twice, but still I give you one more option to make it simpler. See, from the last step, I am going to write R2 as R2 plus R1 and R3 as R3 plus R1. What change would it make? If you add these two, it becomes 0. If you add these two, it becomes 0. So you get these two elements 0. Then easy for us to expand the determinant with more number of zeros. So this will be, if you multiply these two, you get A square, B square, C square. Then the first row will not change. Then when you add these two, it becomes 0, 0, 2. And here 0, 2, 0. See, easy now. When we have more zeros, it is easy. So A square, B square, C square. I am going to expand along the column 1. This is plus, minus, plus. So in this case, plus of minus 1 into, if we delete this column and this row, we have these 4 elements. That is 0, 2, 2, 0. Then if we expand along this element, it becomes 0 only since the element is 0. And the next one is also 0. Then A square, B square, C square here minus 1 into, if we cross multiply, we get 0 minus 4. 0 minus 4 is minus 4. So minus 4 into minus 1 is plus 4. So 4 A square, B square, C square. So this is our RHS. Hence proved. Yeah, it's very easy now. Hope you have learned how to use the properties of determinants. You will enjoy doing when you know the properties thoroughly. It is not compulsory that what I have used, the same property you have to use it. No. If you are coming up with different idea, you are welcome. Unless this operations, the property holds. And then one last problem. hope we will get time to finish up this. Prove that determinant of x plus 4, 2x, 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 x plus 4, 2x, 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 x plus 4, that is equal to 5x plus 4 into 4 minus x whole square. I hope the properties are coming in front of your eyes now. What property can be used? You can guess now. First, you try to add the rows or columns so that you will get a same value in the row. For example, you see, if you add these 3 columns and put it in any place, you get 5x plus 4. Similarly, if you add along row wise also, you get 5x plus 4. So let me do it along the row. Then even here. So we get 5x plus 4 as a common element. So R1 plus R2 plus R3. So this will be, if you add these 3, you get 5x plus 4, and this is 5x plus 4, and this is 5x plus 4. So we have 2x, x plus 4, 2x, 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 x plus 4. And can we take out this as common using this property 4? So this will be 5x plus 4 as common, 1, 1, 1, 2x, x plus 4, 2x, 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 x plus 4. This is a common procedure for any problem using the properties of determinants. You try to make any one row or column having all the elements same. See, I have made the first row as having the common same element 5x plus 4, 5x plus 4, 5x plus. You try to do this one. Almost 80% of the problems will satisfy. If you do this, you will get the answer easily. And then you will get 1, 1, 1. Then you make any 2 ones to 0. That is R2, C2 as C2 as C2 minus C1, and C3 as C3 minus C1. Then it becomes 0. See, we get 5x plus 4 into 1. The first column will not change, 0. If you subtract these two, you get minus plus 4 minus x, and if you do this, 0. 1 minus 1, 0. This becomes 0. And here, if you subtract it, 4 minus x. It's easy for us now to expand. So this will be 5x plus 4 into, when you expand along the first row, you get 1 times, we get this determinant. So it will be 4 minus x whole square. The other two will become 0 automatically. So this is our RHS. That's all. This is the proof. This is the common method. You can try to make any one of the column or row having the same element, and then take it out, and you will get all 1, and then make it zeros, the 2 ones as zeros, and then you expand it, you will get the answer easily. It's an easy method. Yeah. In this session, we learned the properties of determinants and how to use the properties of determinants to evaluate the determinants easily. In the next session, we are going to learn finding the solution of system of equations using determinants. So it's going to be interesting, and also it's an important topic. Usually there will be a 6-mark question even in CBSE and also in NBSE. So don't miss the next session. And for any queries, you can mail me for this address. Okay. Thank you.